Hello friends, I am back with a new problem today. This time the problem is about fluid mechanics. Fluid mechanics plus some concepts of motions also, kinematics. Okay, so the problem statement is here. In the below picture, water level is maintained up to fixed height h. At what height above the bottom a hole should be made so that water strikes the ground at greatest distance? Right, so you can see the picture. This is a container, big container, and continuously water is being pumped into so that whatever the water is coming out of this hole should be balanced, and then water level is maintained within height h. Okay, so the question here it is, at what height y, right, the hole should be made from the bottom so that the water coming out of this hole should reach to the maximum distance, right? So x should be maximum. Okay, problem is simple. Understood? Now let's try to solve this. So I'll try to solve it with two approach. One is quick and one is lengthy. The lengthy is just to verify the quick approach. Okay, so just think from the competitive perspective. So you are sitting in the JEE exam or NEET exam, this problem you are seeing. So you will try to save time, right? So I'll tell you the trick how to save the time in the exam. Okay, so uh, just check on the boundary conditions and then you will get some hint, right? So let's see, y is maximum in the sense y reaches, y is equal to h. If y is equal to h, the hole will be here, right? If the hole is here, there will be very less pressure of fluid on the top, so water will not go far, it will just drip like very close to the bottom, right? So almost this x will be 0. So this is one boundary condition you check. So obviously this you cannot have at the upper layer. Now let's say the hole is at the bottom, near the ground. If you have here, then again pressure is highest here, but it cannot go far, right? Because the projectile motion will not be very far. So projectile motion will just hit somewhere here again, near the bottom of the vessel. So these boundary condition, wherever you make a hole, either at the upper most layer or the lowermost layer, in both case the range x is 0, right? So it should be somewhere in between. If it is somewhere in between, you should use the notion of symmetry. When I say notion of symmetry, it means it cannot be anywhere except in the middle point. By symmetry, it will be in the middle point. So y will be equal to h by 2. So if you see in the answer h by 2, just take it. It cannot be at something like 3h by 4 or h by 4 or anything. It will be in the middle by the nature of symmetry. So that is the quickest approach to solve a problem. Now I will solve this problem with the required theory and then whatever formula we know, right? And then we'll validate whether our answer is correct or not. Okay, so let's solve this theoretically. So, fluid mechanics, you must have heard Bernoulli's theorem, right? Bernoulli's theorem says that what is the Bernoulli theorem? So let's assume that the pressure, atmospheric pressure is P naught. So at the top of the layer, it will be P naught. Now this part is also exposed to atmosphere, right? So pressure at here also, atmospheric pressure will be P naught, right? But now consider this portion. What will be the pressure here? In this same level, but inside the vessel. It will be something like P, right? So this Bernoulli theorem will tell that what do you know? P plus rho gh plus half rho v square is constant, right? This is Bernoulli theorem. Bernoulli theorem. So at the same level. So let's see now. This is one level and this is same level, but the point is here, right? So apply the Bernoulli theorem at the same level at these 2 points. So what you will get here, pressure will be a P naught, the atmospheric pressure, plus this rho gh, right? This is the theorem, you know, rho gh. H is what? H is this much, this distance, this distance. This distance is h, capital H minus small y, right? So we can write here rho g, capital H minus small y. Okay, plus what? Half rho v square. Velocity at this point is 0, right? Because this is a big vessel. So whatever is coming out from here, you will see velocity here, but not no velocity here. That is almost negligible. So this is 0. Now at this point, thus outside the nozzle, at the same level, atmospheric pressure is P naught, right? They know water here, right? So they know rho gh concept here because height is 0. It is open to the atmosphere. So this term is 0. They know water above this point. But there is a velocity, let's say, there is a velocity v here. The velocity v is the velocity with which the water is pouring out from the nozzle. So if velocity is v, then you can write half rho v square, where rho is the density of water, g is the gravitational constant. Okay, now it's a matter of solving this, right? We want to find the value of y and v. So let's try to solve this. This p naught both sides will cut. What it becomes now is rho g h minus y equal to half rho v square. So rho and rho also you can cut out. So you will get v square equal to 2g h minus y. Okay, this, let's say this is equation number 1. Now you must have read in the kinematics, right? This will be a projectile motion. You must have read in the kinematics that the motion of this water will be projectile motion. So water is coming out from this nozzle and then it will strike somewhere on the ground, right? So let's see the projectile motion. The time it will take to reach the ground. Let's see the horizontal and vertical motions of this. If you remember the projectile motion formula directly, you can apply them, but I will try to deduce those formula also. So now consider the projectile motion. We have in kinematics, we know S equal to ut plus half at square for vertical motion of water particle. What is S? S is the distance it is covering vertically, right? So it will cover a distance of y. In how much time? Let's say the time is t. So what will be the vertical velocity? Initial vertical velocity, it will be 0 because it is coming out in horizontal direction, right? So in vertical direction the velocity will be 0 and acceleration will be its gravitational acceleration. So s is nothing but y, u is 0, so this term will become 0, half a is nothing but g and t square. So this gives t equal to 2y by g under root. This is equation number 2. For horizontal motion, now let's see. What will happen in horizontal motion? Initial velocity is v, right? But there is no acceleration in the horizontal direction. The acceleration is vertically in the the gravity is vertical, right? So in the horizontal direction there is no acceleration. So, and s is nothing but x, right? Up to x distance it is striking the ground. So ut is nothing but v t plus half gt square, half at square. So less than 0, so this term will become 0. Okay. Now let's put the value of v and t here. X equal to the v we already found. V will become under root 2g h minus y, right? Under root 2g h minus y. And t also we got under root 2y by g, right? So this g and this g will cut, right? Because both are within under the root. So now let's do a square both side. Square both sides. What will happen is x square equal to 2 times h minus y into 2y, just root will go away, right? Or x square equal to 4 h y minus y square. Okay. Now this is the equation you got. In order to maximize x, what we should do? The rate of change of x, right, with respect to y, the dx by dy, we know from mathematics, right? If there is an equation dx, if the dx and by dy is 0, either there will be a maximum or a minimum value, right? So we know minimum value will not exist at, let's first differentiate, we'll see later. So differentiating both sides with respect to y, what you will get? 2x into dx by dy. I hope you know the differential equation. This is very primitive differential equation. There is nothing complex here. 4 times h minus 2y, right? Now for maximum or maximum, right? For maximum or minimum, dx by dy should be 0. But we know dx by dy is not minimum at for this one, right? Because dx by dy is, because minimum is existing when y is either 0 or y is h. In this case, water will fall down just near to the near to this, right? So in that case, minimum value exists. So obviously here when dx by dy is 0, there is a maximum value. Okay. So for maximum dx by dy is 0, so now it means 2x into 0 equal to 4 times h minus 2y, right? So this term becomes 0 equal to 4 times h minus 2y. What does this mean? It means 0 equal to h minus 2y. This means y equal to h by 2. This is what I had said at the start, right? From the symmetry of this problem, we can say that water will strike to the maximum when hole is at the middle. It means y equal to h by 2. And now this we proved by applying the standard methods, that water will strike to the farthest point when the hole is at middle of the vessel at h by 2. Okay, so what we learned from this problem is always try to use the symmetry if you want to find any answer quickly, and then if you cannot apply symmetry, then obviously you can apply the standard rules and formulas to find out the solution, but this will take some time, right? So that's it for now. We'll see in the next video. Okay, so that's it for now. We'll meet in the next video with some interesting problem.